press Ctrl-Alt-Delete, it will bring up the real authentication screen. So basically this secure attention sequence is the act of forcing people to press Ctrl-Alt-Delete, thus eliminate the probability that they will be inputting their credentials into a fishy program. As simple as that. So what they did is they adjusted the workflow, what a person has to go through in order to access the system, in order to eliminate the possibility of leaking credentials to some undesired program. And they did that because that's how the system is designed. It is designed in such a way that Ctrl-Alt-Delete always goes here first, and only then this hotkey sequence can or cannot be propagated to other processes. Whereas other hotkeys, like for example, Control-C, any process can set up a hook. Well, in more simple terms, any process, any program can be designed in such a way that when it receives this, it reacts in some way or another. But you cannot do the same thing for Ctrl-Alt-Delete, because these are the ones that will handle it. So now you know why they force you press Ctrl-Alt-Delete. It's a small extra step you have to perform before you log on, but this protects your credentials from the bad guys. Another example of how usability plays an important role in computer security is a study conducted by NIST. And I remember the name of one person from the list of authors. Mary Theophanos, or Theophanos, sounds like a Greek name to me. What they did is they ran a series of experiments to determine what the optimal settings for a biometric system are. They did it for some American government security organization, and they asked several very simple questions. Now, when you have to open a door, for example, and let's say you're using biometric authentication by scanning your handprint, the scanner has to be placed somewhere. And the question they asked is the following: at which height the scanner should be placed, at which angle it should be tilted, and a few additional questions. One of them is, how should people be instructed on using the scanner? And the other one was how they should scan. And the options are scan both hands at the same time, scan left hand then right hand, or right then left. And they have some very interesting findings. So first of all, you must realize that if you are some security officer working at the customs in an airport, you have thousands of people passing by you on an hourly basis. And every person has to go through the biometric procedure. There is such a thing as an error rate for fingerprint acquisition. For example, the scanner, I need to put my hand on it, and if I didn't press hard enough, the fingerprint is bad, so I have to scan again. Or if I shifted it a little bit to the top or a little bit to the bottom, the scan doesn't look nice. It's not suitable for this electronic system, so as an officer I have to tell the person, please scan your finger again. And when you are dealing with thousands and tens of thousands of people, every process of repeating an action takes time, it reduces productivity, people are unhappy. That's a bad thing, so to say. So their objective was to determine what are the optimal circumstances for acquiring high-quality fingerprints. And they decided that they should keep in mind the following factors, which I enumerated: the height of the scanner, the tilt angle, the scan order, and the instructions. And the instructions could be the following: text, just some label that says to scan your fingers, take your left hand, put it here, press until blah, blah, blah. So, text. Another option was illustration plus text. Another one was video. They made a short clip, let's say 5 to 10 seconds, which would play in a loop. So you could see what it's supposed to be like when you use it. And then they ran a long set of experiments where they varied each of these factors by a little bit and then measured performance. And they measured performance in terms of scan attempts, time, how long it takes for you to scan, and quality of the obtained fingerprints. I don't remember the numbers exactly, but that's what I'll show you on the slides when we're done with this. They found an optimal height. They did find an optimal tilt. They did conclude that having a video with illustrations is much more effective than text. And they were able to elaborate a set of recommendations for the government, where it was stated that we have formally proved that if you want to have a high throughput rate in terms of number of people per minute, then you need to use these, and those values. And if you do that, you will have, people will get it right from the first attempt, they will spend less time scanning, the quality of the fingerprints will be better. What else they did? Another interesting study, also related to human factors, was photo acquisition. So another part of the US government that deals with the flow of people coming into the country and going out of the country, they have to collect photographs of people, such that these photographs are then analyzed, some special points are located, and the distance between these points is what uniquely defines you as a person. So that's one type of biometric technology. You can't use just any picture. Sometimes they can be too dark, sometimes they can be too blurry. You can stand too far away, or your head can be tilted to the wrong side, or the person holding the camera shook it when they took the picture. So they had the same objective. They had to come up with some kind of a system that would enable security officers to take photographs that are suitable for the biometric database. And they ran a series of experiments to see what matters and how they can choose the interface in such a way that people will get it right from the first time. And I can show you the slides when we're done. But until then, I can tell you a few key conclusions they have found. One of them is that, so this is the screen, this is the view from the top. This is where the camera is located. This is the security officer, and this is the person. The person stands there. So one important thing they had to determine was how to tell the person where to stand. Here, 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 or maybe here. Because if you're not in the right place, you won't be properly focused. So the solution to that problem was, what do you think?
Some kind of box where you stand.
Like
or
an
something.
arrow.
There was a box.
Well, you could have a bounding box. They did it a little bit different. They just drew, well, they took a counter of a person's soul and placed it here. So you just have to stand and try to fit into that counter as nicely as you can. This way, you help people answer the question, where must I stand, without waiting for them to ask you, or without making this guy tell the person, go back or go forward. Or
What if the person is of different height?
Yeah, that's
that is handled by this guy. The camera is mounted on a tripod or some kind of a system that lets them adjust the height with very little effort. And the difference is they took the burden from the shoulders of this person and put it on the shoulders of this person. And that's the right thing to do because this person was trained and they know that you can easily move the camera up and down without much effort. Whereas this person could be a child, a grandmother, a deaf person, a blind person, or somebody who doesn't understand English. And when you tell them, come closer, they won't know what to do. So then you're forced to use gestures or something alternative. Then another challenge they had to deal with was the fact that when you take the picture, the face has to be centered. If it's offset, then it's not going to work out. And they ran multiple experiments to see what's a nice way to deal with this. And eventually they reached a very simple and elegant solution. So this camera is connected to a computer screen, which shows you a real-time picture of what's happening back there. And on the computer screen, in the program, they have an overlay that draws an oval in the place where the face should be. And this little overlay can be used as an aid by the security officer to know how to adjust the camera such that they get it right for the first time. And they ran different experiments with different types of overlays, with or without this little overlay, and the difference was very, very impressive. In other words, when I show you the charts, you can see the actual numbers, where you can quantify how much this improves the situation. So what they did, in this case, these examples illustrate how important it is to test things and try different prototypes. And it's also very important to know how to measure the differences. And when you can do that, you can formally say that a system that has an overlay definitely makes your job easier. Do you have any questions or comments up to this point? I can tell you some examples of a poorly implemented biometric system. When I had to run the paperwork, when I had to do the paperwork for getting to the US, I had to pay several visits to the US Embassy. And they had biometric scanners there as well. And there were several things which were completely uncool. First of all, the systems didn't have any feedback. Well, there's not much space, but I'm just going to explain it in words. So I go to the scanner, I have to place my hand on it, and the first thing I see is a long, an A4 piece of paper with a lot of text on it that says, place your hand like this, then push, then do that. So what they did is they wrote a long set of rules and they explained how to use the system using text, which was one of the options they tried in the NIST study. So I began by reading the paper. My sight isn't perfect, so I had to focus on it so I could see. It was very long, so I couldn't read it in a glance. And I felt a little bit pressure because there are other people waiting in line, and this clerk behind the window probably thinks I'm an idiot because I can't use the system right away. I see it for the first time in my life, whereas she deals with it on a daily basis. Anyway, so I read the text, I place my hand, and then I wait. And she says, press harder. So I press harder. And then she says, press harder still. I press harder still. The problem is that there was no way for me to know how hard is hard enough. And I had to rely on her to provide feedback. What they should have done is they could have something like this. A pressure sensor that would go higher as I press. So when I press it, I see that this thing goes up, and you could use color coding to represent states. For example, you could make it red, yellow, and when it's nice, it's green. So I know that I need to press until this thing is green. And then once I figured what the right pressure was, so I just kept my hand there, and then after a while she says, okay, you take your hand off now. And I didn't take it off instantly, but instead of having it work that way, they could have a little green light that would turn on when the scan is complete. You know, when you use your worker card in the buses or the UPass. You just put it and it blinks green and it beeps. And it's very important because I may be blind and I can't see the green thingy, but I can hear the beep. Or it could be the other way around. I may not hear, but I can see the light. So yeah, this brings me to another keyword which I forgot to mention here, and that is accessibility. You must always think about people who are somehow impaired. Poor sight, poor hearing, they can't move their hand, or they cannot reach something if it's very high. These things happen all the time. Some of us are less lucky than others. So you should always consider accessibility as a major requirement. And it's a very nice thing that here in the US, people pay attention to this. If you notice, any building on the UW campus has a special door. You can just press it and the door opens. Somebody thought about that. And it wasn't like that all the time. In many countries, it's still not like that. It's definitely not the case in my country. And this VPAT, it stands for Voluntary Product Evaluation Template. No, not evaluation, but assessment, or maybe accessibility. It's something, it's a document.
Accessibility template.
Yeah, Voluntary Product Accessibility Template. It's a document that has a list of requirements your software needs to comply with if you intend to sell it to the government or use it in any kind of government-run system. And let me tell you a few examples, what it's about. It's just a checklist. You run through it and you have to answer questions like, does every action, can any action in my program be performed just with the keyboard, just with the mouse, or does my interface contain any kind of blinking text with a frequency of blah 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 blinks per second? And that's important because some people may not perceive text if it blinks, or if they see some graphical element that blinks, they can have a seizure. Have you watched the movie The Andromeda Strain? Well, it's an old sci-fi movie based on a book by Michael Crichton, and the book is called The Andromeda Strain. And there was one fragment in the movie when, so people were in an underground lab, and an emergency took place. Some biological life form from outer space somehow managed to escape the constraints of the lab. So basically it contaminated the lab. And then the alarm went on, and the alarm had so there was a siren, and there was a light which would blink at a certain rate. And one of the researchers just fell down and had a seizure, because it turned out that they had this thing, but the people who designed the alarm system designed it in such a way that it affects people who have certain conditions. So have a look at this. It doesn't have that many pages, and it is a very good idea to make your programs comply with these things, even if you don't initially intend to sell it to the government. Because as a rule, if you make your software accessible to people with disabilities, it usually implies that it's much easier to use for people without disabilities. So if you achieve that, it's a good thing to have. It's another checkbox you can list in your list of features on the website, and it plays, it's an advantage when some government organization has a competition and multiple companies submit their products. Some of them are compliant, others are not. Obviously, it's better to be on the compliant side. Let me give you another example of biometrics and human factors. I must say that my life here in Seattle is much more simplified in this part of the year, because where I come from, it's much colder. And in fact, some weeks ago, when it got really cold, I could see that most of the messages written by my friends on Facebook were about, oh man, it's so cold, or I can't wait to get home, it's so cold, or I forgot my gloves, wow. So temperatures are an issue. Here it's very warm, I mean relatively warm. For me it's like autumn, it's great. Now think about the following approach. In the Orca system used on the public transit here in Seattle and in Bellevue and in Tacoma, for example, you use a card. But cards have a disadvantage, such as I can forget my card, or somebody can steal it from me, and in that case I would have to pay, which is not a good thing. It would be better if we did something else. Are there any alternatives you could suggest?
Other than paying using
Fingerprint.
the card?
Fingerprint scanner.
Okay, a fingerprint scanner, or some hand geometry scanner, or facial recognition, or something of that sort.
But then what about those people who,
No, disabled people.
yeah, I mean, disabled people, like if you use fingerprint scanner and that person doesn't have a hand, then...
Mm-hmm. Okay, so if a person doesn't have a hand, you could use the other hand. If the person doesn't have both hands, you have to give them some kind of an alternative, like pay with cash, pay with the card. So it's always a good idea to have some kind of a backup plan. That's one thing. Second, it was a good thing that you took into account accessibility, and when somebody suggested biometrics, you were able to easily find some drawbacks in that method. And as a workaround, I suggested that we keep cards or some other methods as a fallback approach. Now imagine that you are in Canada or somewhere in the northern parts of Russia, and you use a biometric system for letting people enter a building or pay in public transport. in those countries, when it's winter, it's really winter. And when I say really winter, I say it's minus 20 degrees Celsius, that's business as usual, minus 30, just like that. And people wear gloves. I wouldn't think that I would feel very much discomforted if I had to take my glove off just to open the goddamn door. So in this case, you don't have to think about accessibility. I mean, it's not just accessibility that makes you understand that a fingerprint scanner is a bad choice. Even an average person will be unhappy with such a system because it's not convenient for them. It's very cold, and if you keep your hand unprotected for even 5 seconds, you already freeze. So somewhere here I wrote the keyword biometrics, but it's probably deleted by now. Whenever you think about choosing a technology, always consider how people will react to it. It may look very good on paper. Now, if you forget a card, it's no problem because your fingerprint is always with you. But if it's very cold and I'm wearing gloves, it fails. If I'm a carpenter and my hands are always, with cuts, then my fingerprint may not be recognized at all.
Nice.
Or if I work at a chemical factory and I deal with chemicals on a regular basis, then my fingerprints can be worn out. And some scanners will simply not see anything in there. So there's always a trade-off between comfort and efficiency, and you must keep that in mind. Another example about human-computer interaction and security can be in the context of visualizing information. For example, has anyone ever used SSH to connect to a remote server?
Yes.
Yes.
Yeah.
So,
In some of the FTP clients.
well, FTP is one protocol, SSH is another, but
Secure sockets shell,
Yeah.
something like that. Secure shell. Something like
SSL, Secure Sockets Layer,
that. SSH is secure shell, some.
Secure Shell.
Yeah.
Yeah, so that's the one I'm talking about. So when you connect to an SSH server, it tells you, when you connect for the first time, it shows you some kind of a number which uniquely identifies that host. And if you connect, if something changes, for example, if somebody substituted that machine with that IP address with another one, which is different, it was compromised, then if you connect the fingerprints, I mean those numbers, those hashes will be different, and you can guess that probably somebody compromised the machine. It's not a good idea to connect to it. But what this looks like when you connect from the client is it's a text mode thing. It prints you a very, very long hash. I have to look at it with my eye, and there's no way for me to recognize it from my memory because of this. Nevertheless, the program insists on showing it to me in a textual form, so I get the real exact data. Okay, that's fine. I can, if I'm not lazy and if I'm careful, I can select, I can copy and paste it into my other text editor where I have the other hash, and then I can compare them side by side and see which of them are right. So that's one approach. But you may have seen such a thing as an illustrated hash. Basically, what they do is they take this
They match it with the.
and they generate a small piece of ASCII art. which looks, for example, like this.
Okay.
And if it's different, then the picture will also look different. It could be something completely different. So for me, I'm always used to seeing this shape. When I see something else, there's no need for me to compare numbers byte by byte. I can just look at it graphically and tell you that this is the wrong thing. And I think I shall switch to the screenshots part. Because I have some nice examples of visualizing caches. Oops.
Yeah.
Yeah, that's it. Okay, can somebody help me tweak it? These. Can you adjust the height? I will play with this.
एक मिनट ऐसा
Yeah.
Yeah, we don't need a perfect picture, just make it look good enough.
Yeah.
No, that's fine. All right. There is another person you could follow, Simpson Garfinkel, who is doing research in the field of security. And yeah, let me find my samples. Okay, let's begin with this. Remember I told you about choosing the optimal height for the biometric scanner? So you can see which ones felt uncomfortable, which ones felt better. Now this one is a plot that shows the capture quality as a function of the height. So you can see the 26-inch is a better choice. 42 is much worse. This is the capture time. You can see that from this perspective, 36-inch is the optimal height, whereas the previous one was 26. In this case, 26 turns out to be the longest. So now it's time to choose what's more important for us, quality or capture time. Which height felt more comfortable, average acquisition time, and this is, I told you about the order. You could do left first, right first, begin with the thumb, then the other thumb. So they tried multiple scenarios. And you can see that, again, as a function of the height of the scanner and as a function of the slap order, you're going to have different performance. So would you expect that these things would have an impact? Maybe not, but Now we know that it's a fact that they do. This also tells us about quality versus age. Turns out that older people have,
lesser quality.
yeah, the quality degrades with age. With young people it's better, probably because we are used to gadgets and technology. This is another one, which is interesting. At first, you expose a person to the process of scanning fingerprints and they know nothing about it. So they obviously make more errors. But once you do this multiple times, after several days, your quality improves and you can do this faster. So again, this shows you how much results improve with time for different ages. This is the number of attempts. You see, older people sometimes need 5 attempts per session. Younger people are done with 1. So maybe we should consider optimizing for quality rather than speed, because for old people,
But it's not on a increasing basis, right? 45 tends to be.
yeah, in their age
Not
group.
much difference.
So the general trend, if you simplify it, it's like this. If you zoom in, you see that it's like that. But you know, you can't have one scanner for old people and one for younger ones. Or maybe you could. If you could see that there would be, for example, one age category would be very high and one would be very low, then you could have something like an express lane and a non-express lane, where one set of scanners would be operating at one configuration and another one at another set.